All right, so our first portion of the videos talked about the structure of water as it relates to biochemistry. And in this section, we are going to be talking about the properties of water. So the structure of water is going to give water its unique properties or unique characteristics. These are things that water can do that not a lot of other molecules or other substances can actually do. So as a reminder from last time, water is H2O. That means you have 2 hydrogens and 1 oxygen. And this is what it looks like. Your water is polar. Water is polar, meaning it has uneven sharing of electrons. Uneven sharing of electrons, uneven sharing. And that is what gives your water molecules these positives and negative charges right here and also right there. Okay, so because water is polar, because it has positive and negative sides, it allows water to interact with a lot of other positives and negatives. Because if you'll remember, water, the positives on the water here can interact with negatives on other water molecules, but also with other things. So when water interacts with water, so when water is going to interact with another water molecule, this is called cohesion. Cohesion. This is the first property of water. Water molecules are going to bond with other water molecules. So this is water to water. Now, if you need a way to remember this, the co in cohesion is like the co in co-captain, for example, or co-pilot, or any other code that you can pilot that you can think of, because the co just means same. Co just means same. Co just means same. That means your water is going to be sticking to another water because they are the same thing. Okay, so now we have established that. What does cohesion do for you? When you have a surface of water, for example, on top of a glass, you have a glass. I did not draw it very well. You have a glass, and you fill it up with water. But when you fill it up all the way to the top, now you might see that on the top of your water, once you have filled it all in, so once you fill it all in to the very top, it kind of looks like a bubble. So if you were to zoom that out, or zoom it in, you might see at the top of the glass a bubble that forms. Now this bubble is due to all of the H2O molecules bonding with each other so they don't fall out. So none of your H2Os can fall out like that. Can fall out like so. And that just does not happen because your water molecules all stick to each other. So because they stick to each other, you have a very tense, very sturdy surface over here. That's going to give it something called surface tension. Now, if you'll see, or if you remember all of your biology from before, you notice that there are some of these little bugs that can actually walk on water because of this surface tension. The water is going to be strong enough to hold them up so they can walk on water, and they're not heavy enough to break the bonds, the hydrogen bonds that are holding the water together. So remember, this is your hydrogen bond holding them together. Okay, so this is cohesion, when water sticks to other water molecules that create a very tight surface that cannot be very easily broken by small interference forces. Now, you can also have water interacting with other properties or other materials. So when you have water with another different type of material, this is called adhesion. So we had cohesion before, whereas water with other water molecules. Now we have adhesion, which is just water sticking to other things. Now, same thing as before. Your water molecule can do this because, for example, if we had a piece of glass, let's say this was glass, like a window, your glass actually can have positives and negatives on it as well. It doesn't always have to be zero charge. So anything that has a positive or a negative, your water can interact with. Why? Because water itself has positives and negative charges. So then the positive, as a general rule, positives and negatives attract. Your positives are going to attract to the negatives on the glass. Or if the glass was positive, then the negative here would be attracted to the positive. Opposites attract. Pluses are going to find the minuses and be attracted to each other. So when this happens, you'll see that the water, even though normally water might be flat, might look like it's flat, when you're inside a small tube or inside a small glass, you'll actually see the water level sort of rise near the edge of the glass because water is trying to pull itself up. In plants as well, when you have a sort of plant or a tree, for example in this flower here, that I will draw with red, inside here, on the sides of your stem, your water is actually able to crawl up and up and up using this process called adhesion. So when water travels up, water is traveling up, H2O travels up. Any sort of flower stem or a small tube, like a straw, but smaller, this is called capillary action. Capillary action. Capillary action is one type of adhesion. One type of adhesion. Okay, so we covered those two things. The next one we're going to talk about is the third property of water, density. So density is just how much of something is in a given volume, a given amount of space. So if you have this space here compared to this space, and in space number 1, you have only 5 dots. This is considered to be low density. If you have in area space number 2 and you have a lot more dots, I'm not even going to count these because I can't count them, but if you have a lot more dots right here, this is going to be high density. The important thing here is your low density items are going to be floating, are always going to be on top of the higher density items or substances. So whenever we have, for example, in a glass of water, we always have the low density on top and the high density on the bottom. So all this stuff here is low, and all this stuff down here would be high density. Now, why is that important? That is because water, as a liquid, is going to have relatively high density compared to its ice form. So your ice form of water is actually going to be slightly less dense than your water form, your liquid form of water, the puddle of water. So that means that on a large body of water, you have your large icebergs. Ice is going to float on top of your oceans, on top of your drinks, and so on and so forth. Why is this important? Because when the top of your oceans or lakes or some large bodies of water freeze over and become ice, this protects all of the little fish on the bottom who are swimming and doing their own thing, and they are still able to live because the temperature here is now being controlled. It doesn't get too hot or too cold. It is going to isolate your system from the other outside world. So that is density. That ice is less dense than liquid, therefore it floats. And because it floats, it will provide some protection, some insulation for your ocean life, the animals that live in the ocean. All right, your next one, 4 out of 5, almost done. The fourth one is a high heat capacity. So your water molecule, a single water molecule with its positives and negatives, can actually interact with 4 other molecules of water. 4 other molecules of water. So because it can do this, it's going to be very strong. It has a lot of interactions. So if you want to remove one, remove one from the rest, if you want to say take this and extract only this, you're gonna have to break 1, 2, 3, 4 different bonds in order to separate this one out. So that whenever you have some sort of interaction, some sort of bond that you have to break, breaking this is going to cause or going to need energy. It's going to require energy, and in most cases, this is going to be heat. So water as a substance, as a chemical in general, is going to have the ability to store a lot of heat within these bonds, because making all of these bonds, is going to store energy. So because it can make 1, 2, 3, 4 bonds with 4 other different molecules, your water can make a lot of bonds, can store a lot of energy, and it can also provide a lot of heat. This is why it takes a lot of heat, like a lot of heat, to boil a jug of water. To raise its temperature just even 1 degree Celsius. It's going to take a lot of heat to increase in temperature. This is great because this also means that as human beings, when we go exercise and when we sweat and we release sweat, so when we're hot, right, we release sweat. This sweat allows us to release the energy from inside our body. This removes the energy, the heat energy, and keeps us cool. So because this happens, we are allowed to maintain, or we can help maintain, what is a very important vocabulary word called homeostasis, which is just the inside temperature. So the internal temperature, the internal pH, which we'll talk about soon, the internal whatsoever it is, all of this becomes part of homeostasis. How can we keep this the same? We need to keep our body temperatures and body pH about the same. Okay, that is it for the number 4. The last one. Okay, so this last one here is the number 5 universal solvent. So number 5 universal solvent. Universal solvent. What is a solvent? So a solvent is a word that we describe when we mix two things together. So let's say if we took sugar and we mix it with water, right? When they come together, you're going to get a cup of sugar water, where the dots are sugar and the water, of course, is the line. So this mixture right here is called a solution. When you have two things mixed together, that is called a solution. So in your solution is equal to the solvent plus your solute. Basically, the things that you put together are going to be called solution. So what's the difference between solvent and solute? This is the solvent is this a thing that you have more of, and solute are the things you have less of. So if you look at this example here, I have more water, more H2O, and less sugar. So that means in our example, our solvent is going to be the water and our solute is going to be the sugar. Okay, so now we know that that means water is a universal solvent, meaning it can dissolve or mix with many different things. Universal just means this is true for many things and this is true for many cases, for almost all cases. So solvent just means that you have the more of them in a solution, and that means you can dissolve or be mixed with many other things. So why is that the case? Because, as you recall, water structure. Because water structure is going to affect water function, water's job, right? Because it has these positives and negatives, they can react, they can interact with any other thing, with anything that has also a positive or a negative, right? They can do this. Positives to negatives, and then negatives will go to positives, right? Okay. This is why anything at all, like sugar and salt, sugar also has the positives, negatives, so does salt, so does many of the other items or other elements, other molecules we find in life. That is why water can interact with, or can dissolve, or can mix with anything that has, dissolve, mix with, anything with a charge. With a charge. So that is your positives and negatives. And sometimes we will call this, just like we call water, polar. Some of them can be called polar. So this is going to be a key thing, because anything that is polar will stick to any other thing that is polar. So anything with a charge, a plus or minus, can stick to any other thing with a charge, a plus or minus. Now, nonpolar, the opposite of polar, just means it has no charge. If it does not have a positive or negative, then your polar items won't be interested in these nonpolar things. So your polar do not like to interact with nonpolar. Now, if water is an example of a polar thing, what's something that doesn't mix well with water? Any kind of oil. So oils and fats and waxes, these are going to be non-polar substances. Okay, so to review again what happens with water, the properties of water, to review, number 1, it has cohesion, meaning it can bond, water can bond, can interact with other water. 2, it can be adhesive, adhesion, meaning that water can interact with other things that are not water because of its polarity. It can bond with any other polar item, anything that has a charge. This is also going to lead to high density, where ice is less dense than water. Ice will float. Number 4, it has high heat capacity, where heat capacity just means how much heat can you take, how much heat can you store. And number 5, water is a universal solvent because, again, it can interact with anything that is polar. So water is polar, and anything that is polar can interact with other things that is polar. So polar can interact with other polar molecules. Okay, that is it for my 5 properties of water.